Okay, we're back for the second part here. I want to go over just a couple of things right quick, and just to make sure we get these covered. And I may actually cover them again in the material. I've forgotten exactly what was in that material, but if I do, then that's okay because it's important. Here's our distribution. And this actually fits into a thing that's called the empirical rule, or you may also see it referred to as the 68, 95, 97.5% rule. The first standard deviation, this area right in here, has got 0.34% of the area. This area here, on a normal curve between the mean and two standard deviations, is 0.475, and you double that and you get 95. You double this value and you get 68, which means that for the first standard deviation, this area in here is 2 times 0.34 since it's symmetric, and get you the 68. And then if you go out to 3 standard deviations, which goes from here all the way over 3 standard deviations on the other side, you're going to get 99.7, or it's 0.4985, I guess. I've got 0.499, but that's 3 standard deviations out. And this is the empirical rule. It's a very important rule. You'll see this over and over and over again. We're going to refer to things that are 2 standard deviations away, either at minus 2 standard deviations or at positive 2 standard deviations. Those are going to be, we're going to consider these to be usual values. Between 2 standard deviations of the mean are considered to be usual values. If they're outside of that, they're considered to be unusual values, a lot of times in statistics. So outside of that, if you take outside of the 95, you're going to see that we're at 5%. So 5% is going to be our cutoff a lot of the time on these situations. So let's, I've got an applet here, and let's just look at this. You probably, I just did a search on a normal curve area, and this is one at stat.stanford.edu. But there's several of these around here if you want to play with them. So you probably can't read this, but this is -1 to 1, and I clicked on left. -1, and this tells me down here that the shaded area has got 0.68269, which is 68%. That's what we've said. -1 standard deviation to 1 standard deviation has got 68% of the area. If I click on left, it tells me that to the left of that area, I've got 0.1586, or essentially 0.16. Remember, there was 0.34, so 0.5 minus the 0.34 is going to give me the 0.16. And the same thing, if I go to the right, this number is the same value that it was. So let's change this, and let's go to a -2. And then to the left is at 0.0228, which is, close to the 0.025. It turns out that the actual number that gives me the 5% is 1.96. So if I go 1.96 to the left, then I'm going to get 0.024997, which is just pretty close. So let me go ahead and put in 1.96. These are the values that you'll find in the table. Between those values is the 0.95. We just round off the 1.96 to 2. To the right, you've got that area. Now if I go out 3 standard deviations to the left, 3 standard deviations to the right. Hopefully you can tell me by now, between that is 0.997. That's the empirical rule, the one we just talked about. To the left of that is 0.00134. You double that and you get the opposite, or the complement of 0.997. Okay, so let's go back to the presentation and see where we are. And the shape of the distribution can be determined by the variance. This has got a small variance, and then this one's got a larger variance, which is the amount of the spread. So the mean is a measure of the location, and the variance, or the standard deviation, is a measure of the spread of the distribution. Well, let's, one of the things that we hit pretty hard in this chapter, and again, this should be, most of it should be a review for you, is the z-score. And again, I can't emphasize this enough, that when you start working with the z-score, the table is going to give you some information about the table in the textbook. It will tell you the distance between the mean and whatever value you're looking for. There's half of the distribution is on this side and this part of the white, and half of the distribution is on the other side of that. So it adds up to a full area of 1. The area between the mean and z of 1, the z-score is equal to 1, that's going to be 0.3413. And that makes sense. That's what we said earlier. If we take, this is symmetrical, so we've got 0.3413. On this side over here, we've got 0.3413. So when we go through and we add these together, so what we're talking about is this area right here. Both of those together, we've got 0.6826. Just multiply it by 2, so that's the 68%. Now, if we were looking for the area beyond that, then we know that this side here has got half the distribution of 0.5. So to get that area, we can take 0.5000 and subtract from that 0.3413, and that's going to give us 0.1587, which is the area beyond the z. And both of those values are given in the book. So moving right on along here, if we wanted to get the area that's to the left of this, we'd have to add 0.5 onto this, so we'd get 0.8413. If we want to get the area that is to the right of -1 standard deviation, or a z that has a value of -1, again, it would be the same value, because we're adding 0.3413 to the 5 here. It's an area, so it's not a negative, although it is on the negative side of it. And then there's some other examples here getting areas in between two particular values. And just some practice with those, and I think that you'll be okay with those. Okay, well, looks like I'm going to have a third one, so I'm going to end this one at this time and pick up with the next one.